Welcome everybody, this is page 427, and we're talking about chord theorems. You're going to need a highlighter, and you're going to need a ruler, you're going to need some things to write with, and also be on page 427 with us. Let's talk about things that we're going to be doing in this one. All right, we are going to be reasoning abstractly and quantitatively. We're going to be constructing viable arguments and critiquing the reasoning of others. And so we want to be able to do both of those in our learning on, right here, chord theorems. Chord theorems, all right? So let's see what we can get from this one. Chords and their perpendicular bisectors lead to some interesting conclusions. In this lesson, for example, you will make conjectures about the relationships among some of the special segments of circles and prove theorems about those geometric relationships. You're probably going to need a compass. I'm going to more or less use the resources of the digital copy here. But in the compass, we have this in a straight edge. We're going to be using like perpendicular bisectors and things like that to create specific lines. Here's a circle. It's got a center at point C, and it's got these points, B, Y, and R, around the edge of the circle, which, we'll see what we can get with those. Draw chords, YR, BR, and BY. So that's the two chords that I want, or three chords that I want to make sure are visible. And so, bringing out your ruler, some sort of device to help you draw a straight edge. Let's draw a straight line from there to there. Let me bring out this one. A straight line from here to here. And then draw another straight line. That's chord BY. Draw a chord from B to R. And draw a chord from Y to R. And so those three lines, those three chords that are created, create a triangle. We don't know really what information this triangle has to tell us yet, but we'll get there. Okay. Next up, construct the perpendicular bisector of each chord. So to construct a perpendicular bisector, we should be looking at something in the middle of the line. And so I'm going to use a different highlight color here. About the middle of my measurement puts it along this path. I'm going to go out this way too with it. That's the perpendicular bisector of chord YR. Then I'm going to draw the perpendicular bisector of chord BR. So finding the middle, and then, oops, I need to move this out. Find the middle, and I'm going to draw out through this one. And it's not perpendicular, so I got to make sure that we have a perpendicular bisector line, and then I'm going to slide that right there. This is the perpendicular bisector of chord BR. And then last of all, the perpendicular bisector of chord BY. So drawing this way, perpendicular. What do you notice about all three of those chords? Right? That's what this whole page, or at least this question on the page is all about. The perpendicular bisector of BR, that's this one, happens to go right through the middle. The perpendicular bisector of BY happens to also go right through the middle of the circle, through the center of the circle. In fact, that's what chords, when you look at a chord on a circle and you bisect that chord, you wind up actually going through the center of the circle. It deals with like the radius of the circle and how all the radii of a circle go to the middle. Okay. What do you notice about the relationship? Well, let's just actually comment on that right now. What do you notice about the relationship between the perpendicular bisectors of a chord and the circle's center point? Turns out those two things, all perpendicular bisectors of chords of a circle will meet in the center of the circle. All right, that's the big idea. Let's zoom out. Let's see all of there in its majesty. Back up. Ooh, go forward. Redo, and redo. Okay. All perpendicular bisectors of a circle will meet of chords of a circle will meet in the center of the circle. What else do we got? The perpendicular bisector of a chord also appears to bisect the chord's intercepted arc. Did you notice that? Let's go back up and look at that one. So if we have an arc, we're intercepting an arc. And I think I want to use, let's go with annotate again and choose a different color. Let's choose this one. We've got this like section of the circle right there. That intercepted arc. Not that one. What am I doing? This one. Yeah. That intercepted arc. How does this perpendicular bisector to chord BY relate to that intercepted arc? Looks like it cuts it in half. Is that also true when we go along this intercepted arc? Well, the chord is cut by this perpendicular bisector. It goes through the center, but it also cuts that arc into two equal pieces. Last one, just to kind of prove the point, from B all the way around to R. That's the one that we want to focus on. And it looks like this perpendicular bisector to chord BR also bisects the arc BR into two sections. You can prove this observation and state it as a theorem. So this is how we'll say it. All right, we'll say something along these lines. Not red. Let's go with black. Okay. Draw. Annotate. Draw. The perpendicular bisectors, right? The perpendicular bisector of a chord on a circle will bisect the intercepted arc. All right, you see it? There it is, all of it. Thank you for watching this video. This has been page 427. 428 is next, more chord theorems on the chords of a circle. And with that, I will see you in the next video. Thank you and bye.